If it is already full, I will not be able to add any element to the queue. I should be throwing an exception or just returning. If it is not full is when I should add to a queue. So this is the edge case that we have to take care of. So even before we start to solve questions based on queue, we have to understand how queue works. In order to do that, the best thing to do is to write your own implementation, your custom implementation of queue. Hi everyone, welcome to my channel Code with Ease by Varsha. Today we are going to do a custom queue implementation using an array. So now let's come to the basics of a queue. So many of us try to remember queue and stack based on the acronym FIFO and LIFO. That queue is a FIFO data structure, which is first in, first out. So that is the behavior of a queue, but queue doesn't mean that queue equal to FIFO, okay? So it is the behavior of the queue is FIFO, but queue, a linear queue specifically, is nothing but a linear collection of data. It's like sequential, one after the another, placed adjacent to each other. So it is a linear collection of data, and the behavior of this data is such that when we add an element, so let's think of this as the queue. When we add an element to our queue, and then when we keep on adding, it just keeps on appending at the end. But when we remove an element, only the first element, when we remove an element, the element which is at the first is removed. So the two pointers which are most commonly used is called the front pointer and the rear pointer or the tail pointer. When we keep on adding our elements to the queue, the rear pointer keeps on incrementing. But when we remove anything from the queue, since the first element has to go out, FIFO, first in, first out, one came in first, one has to go out. In that case, the front pointer is being used to remove the element. And then the front pointer goes to the next first element, which is number 2 in this case. So this is the basic functionality of how a queue works. The main operations are enqueue and dequeue. In case of a stack, the equivalent is push, pop. There's one more operation which is peek, which is just to see the element, which is the next ready element to be popped or removed from the queue data structure. So with that, now our problem at hand is we have to use an array. So array, we know that it is a fixed size array because the size of an array is predetermined. So when we have a fixed size array and we have to simulate this entire functionality into an array such that if I keep on adding element to my array, and when I try to remove it, only that element has to be removed which came in first, that is 1 came in first. Now let us see how can we manipulate this array so that we can simulate the functionality of a queue using this array. So what are we going to do in this session is we are not going to write a code. I will be linking the GitHub repository which has all the necessary code snippets of solving this question. But what we will focus on this session is 3 things. First, we'll focus on the thought process of implementing the queue. Second, we'll write down or we'll understand very clearly what are the steps required to solve the problem and the time and space complexity. Okay. Now, talking of time and space complexity, if this is the queue and I have to add an element to a queue and then I have to remove an element. So if I say the element, the operation is push and the element is operation is pop and peek. These 3 elements, these 3 operations, right? Now, what will be the time complexity of this? Very simply, if the queue is empty and I'm trying to add an element, I just simply go and add it to the element, add the element to the queue. How much time is it taking? It's constant. It doesn't depend on how many elements I just go ahead and push it to the array, or I just go ahead and push the element to the data structure. When I'm trying to remove it, because I'm making use of the pointers, try to understand this carefully. There is no need of shifting elements. Okay, so that is going to be the major highlight, that even when you're using an array, you should not be trying to shift elements here and there. Elements will remain as it is where they are. The only game is about the pointers. When I'm adding an element, the rear pointer is helping me to add the element at the appropriate location, and I'm moving the pointer ahead. That is why I'm getting constant time complexity. If I'm trying to remove it, my front pointer is going to help me to fetch the element which I have to remove, and the front pointer will increment accordingly. So that is why when I'm trying to remove an element from a queue also, I'm getting a constant operation, constant time. Peek. If I just do like what is the element at the front pointer, like ARR of front in case of an array, I'll get the element which is at the front. So the peek can also be done. So all the operations are having constant time. And I'm not making use of any additional space. So space is also constant. So these are the complete, like the foundations of queue, which has to be very clear even when you start solving, even before you start solving any questions on queue. So now let's talk about how do we implement every operation that we are talking about. The first operation is push. I have an array. I'll write this again, and I want to push elements to my array. So first, so what are the elements I want to push? So let's have a data set of 1, 2, 3, 4. Simple. Now these are the elements I want to push to my array, but which is a queue actually. Okay. So as we mentioned, there are going to be two pointers, the front and the rear pointers, which is going to help us manipulate the array. So the initial values will be, for front it is going to be 0, for rear it is going to be -1. So let's imagine front is over here and rear is over here. The queue is empty. Now I want to add an element, push an element to the queue. Remember, this is not the queue, but it is an array. Okay. So we have to do the operations aligning with the array. So what we should be doing is, whenever I'm trying to add something to the queue, the first thing that we should check is if it is already full or not. If it is already full, I will not be able to add any element to the queue. I should be throwing an exception or just returning. If it is not full is when I should add to a queue. So this is the edge case that we have to take care of. Nothing but a simple condition. So all of this, you are already going to find the Java code for that in the GitHub repository, but just try to focus over here and try to understand the thought process. So first thing is, I will be checking if the queue is already full or not. Second thing, what I should be doing. Now the rear pointer is -1. I have to add an element over here. What is the index position? 0, 1, 2, 3, 4, 5. So I have taken 4 elements. Let's make it 5 elements for the sake of simplicity. Okay, now I want to add an element index number 0, but rear is -1. So what I should be doing is rear plus plus, and then we should be adding at that index. So I can do something like ARR rear plus plus, and then add the element that I want to add. So at index position, rear plus plus is -1 plus 1 is 0, but index number 0, the element 1 is now added. So 1 comes over here. Now what happens to the rear pointer? Now the rear pointer comes over here, and front and rear are now pointing to the same element. So when the queue is empty, after that when we add the first element, the front and rear are at the same position. Because if I have added to the queue, 1 I have added, so rear pointer will denote that 1 is added. Now this is the tail end, the last element. And also if I want to remove from the queue now, if nothing is there, the front will help me to remove, because this is the last element also, this is the first element also. Okay. After that, the third step, what we have to do is, we have to also keep another pointer which is going to keep track of the size. Size as in the size of the array, because it's a fixed data structure. So we need one more variable. So I will just say size plus plus. The size of the array is increased by 1. So now it is going to be 1. Initially it was 0. So now size is 1. Now the array has a capacity or a size is 1. Sorry, not capacity. Capacity is going to be the initial size of the array. So capacity is going to be initial size, because when we initialize an array, we give some initial size. So capacity is going to be the 5. How many elements we have? I think I have taken 5 elements. There should be 6 elements. So I'll just add one more. So there are 6 elements, and the capacity, the total capacity is 6. Okay. So what are the steps we did? We checked if it is full or not. If it is not full, we are going to add to the index location of rear plus plus, and then add the element and increment the size. So that is all. For pushing an element to an array, you just have to do these 3 steps. Now, similarly, if we keep on adding all the numbers, the elements to this, so 2 comes here, the rear comes over here, the rear pointer. 3 comes here, the rear pointer comes here. 4 comes here, the rear pointer comes here. 5 comes here, the rear pointer is at index 4. Now 6 is added, the rear pointer is over here. Now again, now we have exhausted the data set anyway. So rear is standing at the tail end of the queue. The front is still standing at the front. Now whenever we want to remove an element, the front pointer is going to be manipulated. Okay, so now let's see how does the pop or the dequeue operation happen. So far we have seen the push or the enqueue operation. In queue, we call it like the enqueue operation. So now let's see how does the pop happens. So here we have taken the array again. So let me add all the elements. Front is over here, rear is over here. Now I want to remove the element one by one from the queue. Since one is added before, I have to make use of it. So what I'm going to say is int element. I want to remove whatever element, ARR of front. Whatever front is holding, please return that element. And front pointer has to increment by 1. So front goes over here. I am going to return the element. So first step is this, second step is this, third I'm going to return the element, but front will come over here, so which is now pointing to the next element which can be removed. There's something also called the size that we told, right? What happens to the size? If I removed something from the queue, I initially had 6 elements, now I have 5 elements. So I have to decrement the value. So I have to decrement the value of size, because now we have reduced the number of elements in the queue by 1. So these are the steps which we have to perform to do the pop or the dequeue operation. Dequeue operation. get the element from the front pointer, increment the front, decrement the size of the array to denote that size variable, and return the element, because when you're popping something out, you have to return what element did we pop. So that is about the implementation of the dequeue operation. Now let's see how does the peek operation work. So peek is something which we have already done as part of the pop operation. If you notice this line where we are capturing the element which is at the front. So the small difference of peek and pop is we'll just capture the element which is being pointed by the front pointer and return it. Notice that we are not going to manipulate the front pointer or the size point. Why? Because I'm not removing it from the queue already. So suppose now if I do a peek, I should be getting 2, but I'm not removing 2. So front pointer will stay wherever it is. Size of the array is also constant. So that is the main difference between peek and pop. Next operation, the last operation which we have to do is empty. So this is very simple. You just have to check if the size of the array is equal to 0 or not. Because if the queue is empty, the size should come down to 0 after removing all the elements. And initially the queue, when we are initializing the array first, the size will anyway be 0. So with this, we have wrapped up our today's session of implementing the queue using array. We covered enqueue, dequeue, peek, and is empty. And we have seen in details what are the steps to do it. The code is in the comments below. The link to the code, the GitHub repository is in the comments below. So please go and check it out. And before even checking out the code, I would recommend you to move to your favorite IDE and take your language of choice, and then try to implement this entire thought process that we just discussed on your own by writing the code, and then try to match it with the code that we have written. Of course, it's in Java, but if you are familiar with any other programming language, I'm sure you're going to understand it as well, because that is why I wanted to make this video language agnostic and only focus on the thought process of the problem that we have. Thank you so much for watching.